Hey guys, how's it going? Welcome to another episode of Ferris Makes Hardware. Last week I started working on adding proper trace support to my kaze HDL, which started going pretty well. I think I got some basic dumps working, which is really cool. Now, this weekend, I spent some time actually getting those into VCD format, which is kind of sick. So this is that same test I was showing before. But now it's actually there's two major differences. The first one is that now it's in VCD, so I'm viewing this in GTK wave. So that's one thing. The other thing is actually that this comes from a test, like a Rust test, not just some code that I hacked in main. There's a lot that it took to get here already. So if I go into this main.rs, I think there's actually there's a bit about tracing because this file also still uses tracing. So now it makes a tempter and then finds this, which this is crap right now. Still working on stuff. In fact, I'll bump up my font size, by the way. Oh yeah, that's the file I have on the right. I forgot I had that open still. Whatever. Anyway, now when I make this read cache, I have to pass in a trace object. I think I did that last time on the last stream. I also went through and decided that these can like propagate IO errors properly. So I guess if I were to look at this a little more structured, if I go into kaze, I added some stuff. So first I added this runtime module that kaze now has. This is new, and this only has a trace module inside it. I think eventually it might also have like a random initialization thing in it. That's why I'm putting it under another submodule there. Anyway, the trace just has a VCD module. So I actually went back and forth and thought about like, how am I going to package all these different options for tracing? VCD being the first one, and then later I might add WaveDrom or whatever. I'm not entirely sure. But I want it to be extensible. That's kind of the point. So actually the trace thing doesn't just have VCD. It also has this interface. And I need to document this, but this interface here is essentially what you need to implement in order to accept traces from a simulator. So the main part is this trace trait. And if you implement this, then you can accept traces. And in addition to that, there's obviously a trace value, which is the values you receive. And then there's a type, which the module might also need to tell you about. So the idea is when you create a module, you give it a trace object. If we go back to main, you give it a trace object. In this case, this is a VCD trace. And on creation, the simulator will use this part of the API, push module, pop module, and add signal, to like describe the hierarchy of the module that you're testing. So if I pull up another test, this one isn't particularly interesting because it's just one top level module, but another one, which I'm going to get to, this one, which has actually got a lot more data in it. This has a 2-level hierarchy here. So there's the top level module, which is called M, this particular instance. I know this might be hard to read on the stream, but you'll take my word for it. And then there's a read cache in there as well. And I think I just added like a lot of stuff to this trace. I don't remember what I selected exactly, but the point is that you actually have both, and that the trace actually contains that information. So there's part of the API that allows the simulator to describe the module hierarchy that it's simulating to the trace. And then as you run the test, instead of having it update the trace automatically, I decided to lift that functionality and expose that to the user. So the user actually has to do that. And I was a little on the fence about doing this, but the reason that I chose to do this ultimately was that since it's up to the user to propagate signals, the user is actually the only one with knowledge of when all the signals have been propagated through the design and when it's actually a good time to take a trace. There's really no automatic way to do that the way I've set this up. So just like Verilator and other things, you have to actually manually update the trace, which is fine. So you give it a timestamp, and then the simulator will tell the trace to update its timestamp, and then it will update signal values. So that's why we need a trace value type here, because when we're describing the module hierarchy, we need to describe the types of the signals that are added here. And then when we actually do the trace, we need to actually send in values that are typed like that. So that's like the whole API. And obviously things like update signal and update timestamp and add signal, like a lot of these can give you IO results, because one of the things that's really important is that in order to not explode memory usage, these trace objects need to support streaming. So any of these can actually cause the underlying implementation to output data. So we definitely want to propagate errors in case that happens. So that's why there's IO results everywhere. Maybe eventually I'll have like a trace result that can be extensible by the user somehow, but for now this is fine. And then the first initial implementation is a VCD implementation, just as I thought it would be. And this uses this Rust VCD crate, which I need to talk about. Because while this totally works and it's really nice, it did have an issue with its API, which in particular I can show you because I made a pull request to this and it's already been merged in the last week. And the only difference is that this writer struct that it exposes originally took a mutable reference to an inner writer, and that's not very composable. So I changed it to take a generic type argument here. So you give it, you construct a writer over another writer, and it actually takes ownership of that instead. And the nice thing about this is that most user code actually doesn't change. In fact, this example code here, where you make a buffer and then writer new, and you give it a mutable reference to that buffer, this is still compatible because a mutable reference to a writer implements write. So that still works. And then this allows then this would just take ownership of that reference and then handle all this lifetime stuff for you. So in that case, it still works. And in other cases, this can actually take ownership. Whereas before, if you need to give it a mutable reference, then you need to work out the lifetime such that this writer doesn't outlive or live as long as the mutable reference, which for things like the example that I had where I wanted to create a VCD trace object that wants to own this writer, this is actually a pain because I want to expose the proper API where I accept a writer and take that by value, because that's what you're supposed to do in the Rust guidelines, by the way, which I also mentioned in the thing here, which is also where you can basically get all this information. And by the way, I only saw this because when I was doing kaze, I looked through this checklist. This is the Rust API guidelines checklist thing, which is really nice. Anyway, it improves interoperability, and luckily there was just nothing that happened. I just submitted it, and the next day the guy merged it, which is pretty great. I don't think it's been published though. I think the latest, or maybe it has. I actually haven't checked. But I don't think so. I think that, the latest release is July 12th. Yeah. So right now I think I have my local copy of kaze, I think points to, VCD via mine. This can actually do the official one now, at least, which is somewhat better. Let's run that to be sure. Whoops, that's something else, which I need to talk about. By the way, hi Dark Second, how's it going? Open source. Yeah, this was pretty cool. I didn't, to be honest, I didn't write it in the most friendly way, and I didn't mean to be unfriendly when I wrote this. I just meant to be like matter of fact, because I've been trying to get a little more terse with my writing in basically all contexts, like with my blog and with this stuff and with stuff at work as well. I'm just trying to write things a little more tersely. I don't know why. I just felt like I wanted to start doing that. So I just tried to cut the crap and just write exactly what I was thinking, and that it should be okay. And it was just accepted. So that's actually really nice. However, the performance of this seems pretty bad. I'll restart this actually. So the next thing I want to talk about before I show that is, in addition to the stuff that I had in main, I also went through and took the unit tests that I wrote and then extended those to support tracing. And these are kind of cool now because each one of these tests builds a trace object where you give it, the name of the test. And I kind of just have a naming convention for these tests, which I might change to try and make this automatic. Unfortunately, Rust has fewer macros to determine the name of the function you're in and the name of the crate you're in and everything than I thought. So I was kind of hoping that I'd be able to derive this automatically, but not terribly important. In fact, I actually want to change this really quick because I think I wanted this to be called read cache with the name of the module. Anyway, not terribly important, but what's cool about this is that now I'm running the actual unit tests and they're generating traces. So that's actually really cool. So if I wanted to make one of these, like if one of these fails an assertion, for example, because of the fact that the object itself owns the trace, that when you assert, the stack will unwind and it will still have everything in the file dumped, and it'll flush that everything relatively nicely. So if let's say I do true here, which will change the test, and then I run this, and I think it will fail. Yeah, now you can see read first adder failed. And what's cool about this is it tells me writing trace to read first adder and that it panicked. And so then I can go in here, which, I mean, actually I don't have this open anymore because I just renamed it. So let me close these. In fact, I'll just quit the whole GTK wave. Open it again because, frankly, I don't really like GTK wave a lot because the UI is, I think, pretty bad. But it handles really big traces and it's free. So this is what we're dealing with. But I need to now navigate into this directory again. Ferris, app data, local temp. Yep, that's what it says there. And then here we have read cache, and this in this case was read first adder. So the cool part is now I can pull this up. Yeah, don't tempt me, Dark Second. I might do it. Oh, that's cool. Why core boot? Of all things. So here I can go ahead and add all the traces. And here you can see the test got this far. Now, of course, this isn't telling us anything about the assertion, so you'd have to then cross-reference it with this. So we can see false and true, and then this was line 55. So we know on line 55, this primary bus ready was false when we thought it was going to be true, which we can actually see in the trace. Here it goes down to false, and then that's when things fail. So at least the idea there is you would normally be able to see kind of what went wrong. You actually have some historical context for why that failed, not just that it failed. So that's kind of the point. And then like now I just fixed my error, so I can run the tests again. And now they should pass. And then this one I think already passed, so I can just refresh it. And now we have the full working trace, which is really cool. So this is, I think, going to be a really important workflow. However, now we're going to get to the other issue, which is when I run these, you can see this actually takes quite a while. And the test that it's taking a long time on, let me open that up, open up the trace, which is this with delays. And so what this is, by the way, is I have this, there's a test that reads the first address, which is the one we just looked at. Make sure that works. There's a test that reads all the available memory addresses and just make sure that we can get all the data through the cache. It doesn't actually test that anything was a hit or miss. It just tests that the cache is like transparent. And then the next one does the same thing, but the module that it's testing has a bunch of delays inserted. So if I look at this, you have M, which is our module, and I can basically just add all these. And you can see at the bottom, there's all these delay registers. So the way I delayed this is I took the read data and I just put it through a bunch of registers. In fact, I can show the code for that because it's kind of funny. Here. So yeah, I have this many delay cycles and I take these signals and I just replace them with these register next signals. So it just propagates that through a bunch of registers here, which is fine. It's just an easy way to insert delays from when the cache issues the read to the underlying thing, and then it's going to like sort of simulating that there's a high latency to the memory, which of course there isn't, but this way I can simulate that there is and make sure the cache still reads all the data. Now, of course, because of all that, and because some of these signals are somewhat wide, this obviously produces a lot more data. This trace is a lot more dense than something very simple like this. However, this is only like a couple megs actually. So if I do an ls in this folder and I grep read cache, you can see this read cache read all with delays. This is only 2.2 megs or something, and this is even running the test with optimizations on. So this is really slow. And I haven't profiled this yet to figure out like which parts are slow, but I suspect that the VCD crate is not very fast. And so I may look into that. I'm not sure. I'm going to try to put it off as long as I can, to be honest. This might actually just be fine, but we'll see. I know that there are cases where I want to have traces where I think this will be prohibitively expensive. So it might be something that we have to deal with. But on the other hand, I think this is a great first implementation, so I'm at least going to shelve it until I can figure this out, because the whole point of this exercise now is to figure out this trace API, which I've now more or less done. I just need to document it and also add this VCD one. So that brings me to another thing. I was thinking about how I was going to package these, and I thought about having things like the VCD trace implementation as a separate crate, but I thought, you know what? No, because then I have to deal with things like making sure the two crates, like the main kaze one and then the one with the trace implementations, I need to make sure that the versions line up somehow, and then I need to publish them both at different times, and that seemed really messy. So I thought I would just add this runtime module in the kaze thing as well, so that when you're using kaze to generate code, you include kaze, and then when you're using kaze runtime, you include kaze. So that just made it a bit simpler to manage, even though for either of those two use cases, you're not going to use the kaze compiler when you want the runtime stuff, and you're not going to use the runtime when you want the compiler stuff. So it's perhaps a bit wasteful in terms of compile time, but this is still a relatively small crate, so I think that's okay. And then what I did do is I think I added this trace VCD feature, so you would have to actually request the VCD stuff. And I think I decided that I'm not going to do that, actually. So if we make this not optional, then we have this. I think that's what I want to do. And then I think this will actually fail to compile. Hey, that looks some text. Yeah, package read cache depends on kaze with features trace VCD, but kaze does not have these features. Exactly. That's what I wanted to see. Because again, like it's nice to be able to enable and disable these, but I think it's actually just overkill, because like now I have to specify kaze as a dependency separate from everything else too. So it's just kind of a pain, really. And I can just kind of avoid all that by including everything, which is fine. So eventually I might separate that in a future version, but I think for now the simplest thing is the best. So I'm just going to do that. And know that we have the option to make these opt-in features later. And then I might even like make the compiler opt-in. So maybe you choose kaze and then you decide which features you want, or I separate those in different crates, whatever. Again, in any case, I think this API is good enough. It's not perfect by any means, but it's good enough. And oh, whoops, I wanted to do this as well. Remove that. Yeah, because now these didn't work because those were feature gated. That's funny. It's a good thing that these are leading to compile errors, because that's another thing that I don't like about those crate features, is that suddenly you have conditional compilation. And then as soon as you have that, you should really have CI that at least makes sure you can build everything in different configs. And I don't really want to manage that, so let's not. One thing I do want to do, though, is I want to test, excuse me, I want to test this this trace API. So what I think I want to do is I want to add some sim tests to kaze that generate a simulator that will expect a trace, and then have some kind of like mock trace implementation that will locally store the built up module graph, and then capture all of the things, and then we can compare that against like one that we make by hand as well. So we can run a trace and expect that we can run a simulation and then expect that the trace is exactly what we expected, which I think is a good enough way to test that this API does what we want it to do and capture everything that we need. So that's good. And when that's there, I can finally make like the last decisions, because you can see here as well, like there's a lot of these fields that are generating warnings because they're the wrong case and stuff. And so there might be a couple extensions to this API, because it turns out VCD actually will support different like types of values. So you can say this was a wire, this was a register. And I might want to take advantage of that and have that information there as well. and then also figure out what to do with some of these other signals. Because, for example, in this module, there's this read cache instance, and this has a bunch of memories in it because it's a cache. So, for example, it has these, let's see, data, tag, and valid memories. And these are essentially registers that were generated when you created ports for the memory. So they have these like generated names that are kind of ugly. Now, to be fair, I don't actually care that they're a little bit ugly. It's good enough for a user to be able to understand what these are. What I do think, though, is that the fact that they're ugly means I could probably generate better names for them, at least in the trace. So I think I want to do that. Whew, that's about it. Oh, that's cool, Dark Second. I love those old ThinkPads. I actually played with Core Boot a little bit myself when I bricked some Chromebooks and tried to resurrect them, but didn't get very far and kind of hated the whole experience. Yeah, I bought a Chromebook thinking that it would be a good way to get a cheap Linux laptop, and it did not want to boot anything off a USB. And the only way that you could do that is to patch the BIOS. So I did that, and then it bricked the machine. And so then I bought a second one thinking I just patched it wrong because they were so cheap. And then I bricked that one too. And then then I got some of those chip clip things. I actually have pictures of this. This is everyweeks.com. This is an old blog that I used to do with a few friends of mine. You can see a lot of my entries, and we were trying to write these once a week, sometimes more, sometimes less. And I actually wrote a few entries about this project. Let's see. Yeah, it's kind of early, I think. I don't remember the first post I wrote about it, but this was definitely one of them. Actually, there's a few of these. It's kind of funny. I had access to a nice camera then, so I tried to get some nice. Yes, exactly. Yeah. So I was trying to flash Core Boot on it, so similar kind of things. So this is a Raspberry Pi, and I took some of these breadboard wires and soldered them together, and then stuck that on a breadboard. And this is a voltage regulator, so I could drop. I think it's 3.3 volts and 5 volts here, or the other way around. I don't remember, but that's why I needed a regulator. And then this is a level shifter to shift all the signals. It's super ghetto, this setup, but it's great. And then, yeah, this is the clip on the chip. However, I took more pictures of this if you're curious, but a big issue with this that I found out is that I couldn't actually program the chip like on the board. And I didn't. So what I did is I ordered a bunch of the same chip, and I got this to work on its own. I got the chip itself, the same part to work with one of those clips, right? So then I could test that. Okay, my software setup is actually working, and so is this programmer setup. However, the issue, and this takes forever to load. This is the slowest server. Anyway, this. Yeah, it didn't work on the board. So then I bought one of these. I think I bought a bunch of them, actually, these little sockets for this. So I was going to desolder the chip from the board and solder on a socket. And that way I could, at the very least, take out the chip, put it and program it, and then put it back in. But then by the time the things got there and I went to desolder it, it was way too small. It scared the crap out of me. And I don't know what happened to these, but I don't have them anymore. So I gave up. But it was really fun, to be honest. Yeah, you're lucky that it worked to program them in circuit. That's also another ghetto setup. That's great. I love it. So cool. That's great, man. That's really funny that we both got into Core Boot for the same reason. To make something else work. Actually, on another note, there's a couple posts on this old blog that I might try to move to my new blog. For example, this one that I wrote when A and S clicked in my head. It's really unorganized, but it's got some good information in it. So I think that'd be fun. I have a lot of posts about when I was working on demotivation, actually. So that's kind of cool. Different levels of progress. That's fun. I mean, honestly, I still pay for this site and keep it running only for my own nostalgia and some of the other guys that did this as well. If you guys follow Baggers, he does some Lisp stuff, graphic stuff in Lisp. Now he's working on a game called Tailspire. He's got a lot of posts about all that stuff. Really cool. A few other guys you might know, but anyway, yeah, to me it's worth it to keep these running just to have this up. Kind of fun. Also, there's my first FPGA post actually. This is when I got HDMI starting to work. This is back when I was testing my workflow for my original board was based on Icarus Verilog, where I would run simulations and then move them to the actual board. So I think this came from Icarus Verilog. And this is an I2C master, which you can see, you can tell because it has this clock signal, and then you have these high impedance parts at the ends. And this is where it's reading data. So it's trying to read and write some registers. And in fact, I think that's what this was reading and writing registers to enable the HDMI transmitter chip. And I figured out a bunch of interesting stuff about that and a bunch of annoying stuff about that, but eventually got it working. So always fun to look at this stuff. But I basically didn't touch any FPGA stuff for a while after that. Oh, and actually there's the original kaze, which originally was just a little build tool. Now it's, of course, my hardware language. So that's pretty fun. Also, yeah, this one, for example, is this big write-up I did on how I architected demotivation. That would be cool to have, but it needs to be updated. I've got a bunch of C64 stuff on here, too, about reverse engineering some of the effects. And also starting Rush Duel Boy. This is so cool. Sorry, I'm just in my own little world here now. That's fun, though. Yeah, this is a proper tangent. These screenshots are kind of cool, though. These are, I was looking at Edge of Disgrace to look at how these plasmas worked before I did Makeshift. When working on the plasma that eventually became the thing in Makeshift. So that's kind of fun. And you can see it's all fucked up because I was in a debugger and I was like changing the code so that certain register writes wouldn't do anything and just kind of analyzing how this effect worked. This is, I think, the most targeted testing I did on it. Man, that was really fun. But I also have all those notes available on GitHub, I think, in this repo. Codebase stuff, full notes here. Yeah, I took a lot of notes when I did that. That was really fun. Yeah, Ferris makes nostalgia. Ferris indulges in his own nostalgia. I should do some more effects where I tear them apart like this, especially in the new C64 debugger, because that was really fun stuff. Would love to do that again. Some later stuff. Anyway. Yeah, lots to do still because, first of all, this tracing stuff is not, you can't disable it right now. So if I wanted to go to another one of these sim projects and try to build those, so if I went to like the Buster sim, if I did cargo test, actually this might not build because it's pointing to local kaze rather than the other one. We'll see. Yeah, this is because 2 different crate versions are being used. I'll just actually change that really quick because this is useful. Yeah, now you can see it generated a bunch of this trace code because that's not optional. And then, of course, it failed to build that generated trace code. So I need to actually make the tracing stuff optional, which I didn't do initially because it was easier not to. So that's another thing that I have to do. So I have to extend this API to generate code. In fact, actually, probably the best way to test that is to go into the kaze directory. If I do cargo test here, I think that will fail there. But anyway, I just wanted to say that I was very happy with that Rust VCD crate because other than that one API issue, which I did work around initially, but then I didn't want to make my API dirty, so I forked it and fixed it and did the pull request anyway. Other than that one very small issue, the thing just works, which is really great. Even though it might be a bit slow. It probably hasn't been like really battle tested when it comes to that stuff. So I think this is a really good use case for that anyway. But yeah, we'll see. We'll see if I make more contributions to that crate, or maybe if I do something like it might make sense for me to just do my own thing for this anyway, because for example, my simulator will never produce unknown or high impedance values, which these tracing tools and this format has support for. And if I don't need those, then I can simplify the API and make it only what I need. And then like that alone, I think would make it a lot faster already. It also might just be that I should, whenever I do these traces, I should put them in like a buff writer or something like that, just to buffer up all the commands. And that might be enough. So I'm not really sure. But yeah, I think the first thing I'm going to do here is make this tracing stuff optional. So I'll just dive in with that. I'm not that focused about how I'm doing this and like in what order I get to this list of features. I'm using this ticket I made as sort of like a high level overview and things I don't want to forget about, but I'm just kind of putzing at it until I get what I want. Mostly because I think this is really boring. Because it's not what I want to work on, but it's something that I think I need that will ultimately be really helpful for what I'm working on. But yeah, it's kind of boring, so I'm just kind of putzing at it. Anyway, yeah, for these tests, actually for the API, that's the most important thing here. For sim, I think what I want to do is basically this. I want to have a pub enum, or actually struct options. And then this something like this. And then this would explicitly derive default. I think I want that. There's also some code cleanup that needs to be done. I think the way that I handle some of this stuff for generating trace signals was not very clean at all. Which is fine. Like, this is sort of proof of concept. In particular, this visit context stuff here. Actually, this proper hierarchy, that's kind of done. But I think, yeah, this code needs to be cleaner, or I need to put it somewhere else. I'm not entirely sure how that's going to look yet, but I think that's fine. Basically, what I want to do now is put all this stuff in if statements, more or less. And then I want to get a test. Like, I want it to build the existing tests, and then I want to go back to the other test that I had and make sure that builds. So then I kind of know that it works in both cases. And then I want to add some targeted tests to the sim test suite. And I think it'll be like more or less feature complete. And then I need to clean up a lot of the code, document stuff. Kind of a big investment to do this, but not as bad as I thought. And actually, again, I think I mentioned this already, but kind of cool. Since now we have this kaze runtime sort of paradigm in the way that we do trace, and also introducing this generation options. Like, I'm making this kind of extensible on purpose now because I know that eventually, where is it? Yeah, come up with random initialization solution for generated modules. So here I also want a user to be able to optionally opt in for random initialization, a random initializer trait kind of thing as well. So similar to the trace, you would pass it like a reference to this random generator thing, and then, yeah, it would pull random numbers out of that. Simple as that. I also I added a couple more issues here that I thought were kind of interesting. In particular, this one. Lift signal bit widths into the type system when Rust achieves proper support for constant generics. So this has been on my mind for a while. Right now, signals in Rust in the API, they just have a bit width field. But I think this totally could be part of the type system once we have integers in generics. And I think some of this stuff exists on Rust nightly right now, but I'm trying to support stable. So I got to be patient with that. But obviously this would be a really nice thing to lift into the type system, because then we can just remove a lot of code in the compiler, actually. This would definitely be a breaking API change, but one that I'd be very happy to do. And in fact, in kaze in general, I have intentionally kept the version numbers 0.1 point something, because I'm pretty sure in Semver, anything 0.1, in fact, I think anything below 1.0 is actually signifies breaking changes. So even though I'm sort of treating this as like, isn't it when you do these minor versions, I think you do, it's major, minor, and then something else. I have the doc here. Major, minor, and patch. Yeah, minor is when you add functionality in a backwards compatible manner, and major is when you make incompatible API changes. So I've kind of been treating this the same way anyway, except I did actually bump I'm pretty much only bumping patch versions, which mostly has been true because I've mostly just been making backwards compatible stuff. Actually, that's not true, because I've been adding a bunch of functionality. So I've actually been using this wrong. I mean, it's still correct because it's, as you say, it's below 1.0, so I can do whatever. But I've had this wrong. I should be bumping the minor versions when I've been bumping the patch version. But whatever. So I'll definitely revisit this. But yeah, most changes I've been making actually fall into this category. I just keep adding stuff. Except I recently made a change that was not backwards compatible. What was that? This is why you keep a change log. Right. Yeah, the generated sim modules used to implement default, which is not correct. I use that as a shortcut to simplify code gen. but it wasn't actually correct anymore after I added memories. So this should have been done when I added memories. And then, of course, that would have been a major version bump had this been actual semver. But it's too early for that anyway, so whatever. Besides, I actually am happier if people don't use this because then I don't have to support it at all. But even then, for my own sake, and because I think I'll use this project for a lot of my projects moving forward, I think it's nice to keep everything up to date and do documentation, everything just for my own sake. Like, I was so refreshed and didn't actually expect it when I was hovering over stuff here and I had like proper documentation because I'd written it, right? But I didn't expect the editor to be integrated with that. So it's kind of nice. Anyway. Yeah, then I would add random init, other options for code gen. And then I might use this pattern for Verilog as well, if that actually makes sense. And then it would have its own kind of generation options for Verilog, which would be different things. So that makes sense to be a different struct. But yeah, I'm super happy with the VS Code integration for Rust. Also at work, we do a lot of things over like SSH to other machines, and I'm really happy with VS Code in that context as well. You can connect to remotes really easily. That's really good. Really happy with that. All right, I've been talking for an hour. Actually, I haven't been because I started late. I've been talking for about a half an hour. That's pretty normal, isn't it? Yeah, so now this generate call is wrong because we have this options here. But I want to start using this first before I actually fix that. Actually, no, let's fix that first and just let the compiler tell us what to do. That sounds fun. So this is SimRS? No, can't be. Oh yeah, it is. It's the tests here. That's what it is. It's these ones. Yeah, I use a vector for the writer in these cases when I just need a dummy. That's fun. Yeah, so this will be... Yeah, you just do default for these. Easy. I'll just do this a few times. I don't think any of these tests actually test that anything's generated. I think these are all just for errors. And I think I test all the sim stuff only indirectly via the generated module's behavior. And I think that's a good idea because then I can decide to internally make the simulators work a different way or rename fields or whatever, and it doesn't actually affect anything. So I think that's smart. Now we get some unused variable warnings, but we'll fix those as we actually implement it. And then, yeah, now we get them in the build script, which is where I expected to get these errors. So then we need to go into that. So it's these kaze sim tests, build, all this stuff. So I think here it's the same thing. I actually do want to do it where I add this like by hand to all these. Because I plan to have specific tests where I override these. So yeah, I think this makes sense. However, this needs to be qualified like that. Yeah, to be fair, I don't like working over SSH a lot of the time, but we need to do it for big machines. A necessary evil. Yeah, and again, this is because that this default is not being respected. So the way to fix this is just to add if statements to not generate this stuff, I think. I think we can even do this here, which is kind of cool. At least that helps for part of it. This is really mechanical stuff. But I think this is a fine approach. This is just stylistic stuff, but I think I want to change where I have these spaces. It doesn't matter, but I seem to like that better. Oops. Yeah, append new line. Getting there. That'll help, but then we need to break down this line as well. I'm just going to do this again. This is going to be new. Yeah, and this instance name and the trace stuff. this is all different basically. I'm actually going to do this. Yeah, I guess let's do this. Yeah, a little bit of redundancy in this and the arrows and stuff, but in this case, I think it's just more readable to have that redundancy than to try and factor it out. I think that's reasonable. Getting there. In my experience, this kind of code always gets kind of messy, especially when you start adding conditional stuff like this. So that's one of the reasons I've been really hesitant about it. But I think once this is covered by individual tests for different parts of it, I think that really helps at least. And then we're able to kind of make meaningful changes to help with that later. So I think I generally did this right. There's one compiler I worked on professionally that I didn't write initially. This was a couple jobs ago. But I didn't write it initially, and then I came in later and had to make some modifications to it and just couldn't without breaking something. And we did not have nearly enough tests, and I spent a good month or so just adding compiler tests for like a bunch of different parts of the compiler to finally start making changes. Anyway, it was a huge pain in the ass. You really can't do this kind of thing because like even now, just adding all these conditionals doesn't seem that complicated, but this code gets so unreadable. And this is just one option that I added. When you start getting matrices of features, this gets really nasty. So yeah. What's this? Libdaris 31. What's that doing? Oh, doc tests. Oh, thank you, Rust, for having doc tests. That's awesome. That was in here for this. Cool. That's fantastic. That makes me really happy. But yeah, I definitely know from experience that, especially when doing compilers, they're so easily testable compared to a lot of other projects that you really don't have an excuse not to do that. And like a lot of other kinds of software, it just becomes such a brick if you start relying on it and don't have these kind of tests. Anyway, that ran. That's pretty sick. So I bet if I go in this read cache stuff and I run this will now fail to build because we don't have those options for generation, which is great. That's what we wanted. And if I add them, something like that. That's what I want to do. Probably could have reused this, but who cares? Good enough for this. Okay, I didn't split this up right. That's fine. I think it's this. Also, this space actually isn't what I wanted, because you get a space here, which is not what I want code style wise. So actually, that is what I wanted. But second of all, we still don't have this T, which is what we need here. Yeah, I wish. Yeah, run Rust format on the generated stuff. That'd be funny. Yeah, I'm just gonna do this the ugly way. Like that, and that will have the same error. Oops, yeah, because this now looks like this. Okay, and then, yeah, this is formatted right, and we're missing the type argument, which is going to go right here. And this is another case where I might refactor this just to be a little bit redundant, but then simpler overall. Maybe I'll change this. We'll see. I don't need to, but I might. So I still don't like that we get all these warnings. We'll get to that though. We'll see those as well when we go back to the other tests. But this should all work. Traces are still valid. Looking great. And then if I go back, all these should pass as well. That's very true, Dark Second. Yeah, tons of warnings is pretty standard for FPGA stuff, and I hate that. Absolutely hate it. Oops. But yeah, this is great. So now we've supported both cases, but now I want to add tests, targeted tests at generating simulator stuff with with just kaze. That should be representative of everything else in the other directory. So let's see. Yeah, here like mem test module 0, all this stuff. I'm basically going to copy that paradigm, I think. Something like this. Like this, and then here we do trace true. And again, the reason I'm writing it out like this is so that this code is actually future-proof once we add more options. It's pretty cool. We need to actually write this function though. I'm just going to do something simple here to start out with. And one of the nice things about having all these tests is that they're good examples of how to use kaze actually. So all these are relatively easy enough to read. Oh, I hate that Rust format got to these. I wonder when that was actually, because I thought I was writing these such that this wouldn't, or that I was ignoring Rust format for this or something. Yeah, I actually don't like that. It must have been in this commit though. Unless I did it some other time. Just didn't think about it. It wasn't here. Maybe it was just like that for a while. I should git blame it. That's what I should do. Okay. So actually, it was when I implement it, which is really good because that means I didn't just change it when I did another commit. So I'm at least happy about that. I probably have a note about that here, actually. Unfortunately, Rust format doesn't seem to like it. That's what it is. But okay, that's the best case scenario for that. So that's fine. It must have been warnings that I remember seeing in some other code. Not important. Anyway, doesn't really matter what I do here, actually. A bunch of these to get different data types. Easy enough. And then we'll go into the source, because in lib, this is where the test code actually lives, or where the actual tests for the function live. Wait a minute. Weren't there a few of these mem test modules? 0, 1, 2? I see 0, 1. Was there 2 here? Yeah, there are 2. Good. I think, though... Well, actually, it doesn't really matter. This is really common when I write these kind of tests. I just fork another one that's similar enough. Nice and easy. I'm actually going to remove most of this, though, because these are mem tests, and those are kind of complicated. Do this, because first of all, I think this won't build even. Oops. That. I think the cogen will work, and then I think... Oh yeah, now we need to also do this. In kaze sim test, we need to add regular dependency on kaze as well. For the runtime stuff, that's what this is telling us. Yep, and now that built, and now it's the test itself that doesn't build, because this takes 2 parameters. One of them is the instance name, and the other one is a trace object. And here we need to do some helper stuff. I think all this is in a test module. Yeah, I think it's probably fine to have this here. I'll add it to do for myself. Let's see. I don't want to call this mock trace, but we'll go with that for now. And I actually want to pull up the VCD implementation just to have that as a reference. Actually, I don't know if we need that. I think we do need that. Whatever. So we need yes.io. I think as well. Full trace. Oh yeah, that's from super in this context. Yeah, so we need yes. Like that. Yeah, and this will do this as well. No, we don't need this to be right. We don't need that at all. But yeah, we will do impl trace for mock trace. And we'll do these same signal IDs. That's a fine idea. And I think, how do I want this test to look? So I want to do something like this. And then you give this the trace. This will be something like mock trace new. We're gonna do some to-dos, and then we need to do, cert EQ. We might actually have to change the API to make this more testable. Because with this, there's no way to get the trace back. I guess there is, though, if we... If we did something like... some trace thing here. And then we made this take like a mutable reference to whatever this thing was. And then later here we would do assert equality there. That's kind of a good idea, I think. Because essentially what I want to get to is something like this. Root. Yeah, like the point I'm trying to get at is that I want to make this wiggle things around a bit, and then at the very end assert that the trace that we stuffed into all this API has a certain list of signals like this. That's what I want to get to. hate calling stuff like trace data. Ugh, I hate putting the word data in the name of a data structure. That always makes me sad. I want to call this trace actually, but I like that the trait is called trace. That might work. All right, so then we have something like this. That's fine. I might rename stuff. But I like this. You make a capture. You provide a trace around that. You let the module borrow that trace while it's doing its work. And then at the end, you check that the capture is equal to what you expected. I think that's quite all right. And I also like that this way you definitely test like the behavior of the API in kind of a nice way. And I don't know, I probably want tests for the VCD implementation too, specifically, but at the same time, I'm a little hesitant because like the VCD crate might change how it encodes things. So then it's almost like I'd want to round trip that data and then check the parse stuff. And I don't know if that's something that's even really worth doing. As long as I know the API works as expected, I don't think it's unreasonable to expect that this stuff more or less just works, but whatever. Well, we'll see how I feel about that once I do more testing. Anyway, this will do this, I think. Actually, this needs to be pull. I can just call these name, actually. You know, and I'm going to make a choice here. Instead of using vec for these, I think I want to do like a hash set or something, which is sort of my way of signifying that I don't care about the ordering here. Because otherwise, if we use a vec, then we expect these same elements in the same order. And that's just not what I want for this. Also, we need this. And we might need to derive debug for this too. Because I think assert EQ needs these to implement debug in order to print what they were on failure. Let's see. You know, I'm actually going to make this a hash map instead. Because we need to return IDs for these signals that then we need to index later. So instead of a hash set of these, we'll do a hash map from usize or U32 even, because who cares? Make this whatever I want. And then this will be, yeah, like that. Like this. And then we want a type. I think for that we can, let's see, so let's have this open here for reference as well. And I think it's quite reasonable. In fact, I think there's the Rust API guidelines to make sure that certain traits that you can implement, you always do. In particular, to implement as many of these as you can, basically. Now, I think I haven't necessarily implemented all these on other types. Maybe I have. Let me check. I really don't think I have done this very well in kaze, actually. And I always feel like skeptical about whether or not I should add tests for these kind of things. I'm never that sure. I don't know, the graph API probably has some of this stuff. Constant, maybe. Yeah, this actually doesn't implement any of those. Yeah, I don't think I've done this at all, actually. I just had a thought when I saw this must use attribute that I should actually probably decorate some of the new API with that, but I don't think I need to because everything returns IO result, which already has that marking, so I think I'm good there. But yeah. Anyway, these definitely will need to implement those things too. And I think it's fine to do that. Derive Q. And then more. And I can always just add more later. I'm not that bummed about it. I mean, it's annoying because if a user wants to come in and then just expect these to be there, they're not. And then they have to go through me. But I only really care about that user if it's future me. So I can always just fix that later. Yeah, I expect I'll have to add debug as well, but I'll let the compiler tell me that. And then, yeah, we have... No, these actually don't require more fan out because of this. However, actually, I'm going to do this too. This is going to be a timestamp value pair. Just so that I test that those are being propagated correctly as well. That's a good idea. And then I can actually expect that these will have some kind of ordering by enforcing them with these values. And then you do dot into iter.collect. And I don't know why that didn't work. Probably because these capture signals are wrong. Yeah, that is why. I'm not actually entirely convinced that this is the best way to do this for this API when I think about these trace value types. Like, obviously the values need to be typed because you need to wrap these. You need to know which one of those it was. But I actually think this trace value type is probably redundant. It's just that I feel like, because you get the bit width of the signal, which also we should have here. And just something felt wrong about only giving it the bit width, because you can derive what you expect the value type to be given the bit width. But I kind of felt like that mapping was up to the compiler. I'm not really sure. So I think the bit width is technically all you actually need, but then I don't want like user code checking that a given incoming value fits in that width. I don't know. I'll stick with this for now and I can change it later if I don't like it. In any case, this information is actually kind of useful as is because, for example, like at least if I were to drop something, I would drop the type because the bit width is definitely useful to have. Like this, it'll give me I expect U32 values to come from the trace, but the actual signal has a bit width of 2. That's a useful distinction. But yeah, this capture signal needs values. Something like that. Something like this. Yeah, I like this approach a lot. Let's see. we need to build up the modules like this. In fact, actually, I kind of want to do this. I expect build errors, which is good. Traces module 0 new needs 2 parameters. Is that not what this is? One 779. What? Oh, that's another older build. That makes sense. Yeah. So 1845. That's this one. New not found for capture. Yeah, that makes sense because I didn't implement that here. And yeah, we need debug for these as well, which is what I expected. So that's great. And that will require these ones to be debugged as well. Which is fine. These are all trivial types, so that's great. Yeah, thread panic not implemented at 1830, which meant this was called, which is perfect. That's great. I have to think a bit. I don't think this will be that bad, actually. Yeah. So capture trace needs some kind of context as it's building up this module thing here. Something like that. I think I want this. A little bit messy, but certainly reasonable. I don't know what it doesn't like about this, but whatever. Oh yeah, this is supposed to be none. That's why. So this way our initial context is that we don't have a module that we're currently building for the hierarchy, and it has no parents. That's basically what this means. And so to push a module, we do if let sum current module is self.current module and self.parent module stack dot push current module. And this is not correct. We need to make a new module. So this will be like that. Okay, and then pop is a little more complicated. Because when we pop, what we essentially want to do is take the current module like we want to take the top off of this stack and take our current module and then add it as children here, which I actually don't think I added here. I'm thinking about whether or not I want this to be ordered. And I think I don't. So for example, a graph, say a graph. A module has several instances. Of other modules. Actually, this is another good place to use a hash map, because I think what I actually want is hash map, and then you have a string here, or actually maybe I want static string there, maybe not. I think I need to use a string here. Yeah, I totally could do the whole thing, the whole stack with just the vec. I think I like this pattern better. I mean, it's worse in the sense that you have two fields that you have to keep in that have to agree with each other, basically. But I think it's a little prettier this way. Something just happened with my sound card. Can you guys still hear me? That's weird. Maybe it's just Spotify that messed up. I'm listening to music right now. And I would like to continue doing that. Cool. Spotify's not responding. Okay, so Spotify just ate shit on me. That's annoying. And it's updating apparently. It's annoying. Okay, I'll let that happen. But yeah, like totally, I could have the current module always be the last one in the stack. That's definitely something I could do. We'll see. Maybe I'll make this work and then I'll see if that change makes the code cleaner. Probably does, actually. Okay, I'm still not hearing anything from Spotify, so I'm just gonna give up on that for now. Whatever. It's annoying. Anyway, yeah. Capture trace. So yeah, by the way, this is one of those things where it's like, do I make the module a name like this? Or do I make the name... Do I rather have this be the name, the string here? And then every time when you want a module, you actually put those two together. I like that better for this storage here, because then you could look those up by a string. I mean, you wouldn't ever have to in this context, actually. This, again, is where I would want like a hash set. Yeah, this actually kind of sucks. Because these signal IDs that we return, I made those U32 to like identify them, but they could. I actually almost want these to be RC capture signal, and then use internal mutability for all these, for the values. Like if I do ref cell here, and then have this be RC like that. And I have no idea if that works for something like this. Because I actually realized I wouldn't, like I thought I was going to index these by the integer, but I actually won't. So then this signal ID would actually be RC capture signal. And that way this root captures the name here, and the children also capture their names like this. And then I think this actually might have to be a string. Actually, no, because we're always going to get them pushed by static strings here, and same with the signals, so that should actually work out. Yeah, okay. I think I'm going to do this. I don't normally reach for like ref cell and RC this early, but I think this will be the easiest way to write this. Yeah, I guess I could do cow. Or can I? Because that's copy on write, and that's not what I want to do. I want to have references to them. You know what? I think I will just make this module stack a vec and just do that. And then it'll just be empty initially. And for things like this, I can pop it. Actually, I don't even need to do that here, because I'll just push a new one. So it's literally just this. Which is even nicer, actually. And in things like add signal, I can use vec last mute to get a reference to that. And then for pop, I'll basically, well, I can use pop because vec has pop as well. So that's pretty good. So to pop the module, it's something like this. Just unwrap everything. Yeah, I'll just use the stack until the module is done, and then I'll add it to its parent then. And then those don't even need to be mutable or anything. Like it won't resemble a graph as I'm building it, because you only really update the latest one, and then you can push that in there. It's kind of a stack within a stack, except the structure here doesn't have like ordering. It might be a little weird. We need the timestamp on this trace as well. Okay, and then we do current module dot. Yeah, this will be insert, isn't it? Merge children, not push. And this will be RC new. And yeah, also this will return ret. So actually what we want to do is let ret is this. This will insert ret.clone. So just clone the RC and then ret. And this will be RC capture signal. Name, and then what else did we have? Yeah, bit width, type, and then values, which is going to be, yeah. Like that. Oop. Right. That. And this did not like that. I decided that these are going to be RCs, I think. Was that? I think it must have been, yeah. Yeah, that wasn't that as pretty as I hoped. Maybe there's ways around that. This I don't like either. Oh, that's actually okay. Because I think that's just the capture module. It doesn't implement the right stuff. Or it does. But there's definitely some hash things missing, which I think is why partially Q. I'm actually not sure. Yeah, I could make that easier with macros, couldn't I? Let's add hash to this list. Trace value type doesn't have hash implemented. That's correct. Actually, I might as well add it for this too. Oh yeah, hash is not implemented for the hash set itself. Yeah. Probably better that I have hash on here, but I don't want to add anything until I know I need it. Yeah, I might need to think about this because I think it's important that we use a structure that doesn't enforce some ordering. But I think most structures, like these sets, will require us to do like hash or ord. Because like a B-tree map needs some kind of ordering. So that's why we couldn't necessarily use that, or B-tree set, I mean. And I really don't want to accidentally enforce an ordering with this check. So maybe I'll have to do my own collection with equality or something. I don't like that. Yeah, I could do a string hash. Like instead of doing a hash set, I could pull out the names of these and make that like the first part of a hash map. That would work. Yeah, exactly. Yeah, I'll do that. Let's make that a hash map. They're even these static strings, which is even better. I will pull the names out of the modules and stuff. I'm going to do this for that, so I don't duplicate that information. It's not as pretty, but there's no duplication of the structures that way. And then the root is a little awkward. I mean, it's okay though. I could even do this, which is fine. I could even do it like this. All right, I'm going to remove these hashes. I don't need them now. But yeah, if I do struct capture root, just to give these names. And this becomes capture root. Did not like that. Oh yeah, because I forgot this. Really, hash is undeclared? I must have just did that wrong then. Yeah, these should be hash maps. I don't like the RC either, but it's like the easiest way to make this work, where we return an ID for it from add signal that then the trace object captures, and then the trace will tell us to update signal values and give us that same RC. And then it's really easy for us to just unwrap the current signal from that. That's why I'm doing that. So I think that one might stick around. But yeah. Also, yeah, this module stack now is like this. Is a pair, because we'll have the name. In fact, I'm actually going to rename this. Name module pair. And then the stack will be that. Actually, I think I want to... I'm actually going to move this back. There's a good reason for that, which is that I want... to destructure that here. Yeah, that's true. I could have aliased that as well. That's true. I think I actually like it better without. If I'm just using a tuple, but maybe I'll change that. We'll see. Yeah, and then this is this. Okay, 1905. Apparently I used hash set. Yeah, here. And then here we'll do this. I think that's... yeah, something like that. Right, so module stack, last mute, unwrap, dot. Just do dot one for that. One 849. Is that not what I did here? Oh yeah, again, old. Whoops. I looked at the wrong results again, because now there's just one error, 1863, which is this one. It's the current module. Right, so then we'll do this. In fact, here I'll also rename this current module to be consistent. That even ran, which is great. Although it tried to unwrap something. That's annoying. Not what I expected, to be honest. I don't think I would have popped the root because I push here. It might be. Yeah, this is what I didn't do. If this is what I didn't check. If the module stack is empty at the end, I think that's what it's going to be. And then, so I think it's this unwrap that fails. So I get maybe that's what you mean. But yeah. If there we go. We do put the root in the stack already. Because the trace will generate the entire module hierarchy, including the top level one. So push module will be called initially. And then at the end, we need to handle the case where the stack is like we just popped off the root, and then there's no parents on the stack left. That's what it is. Right, and now this actually needs to be sum as well. Right, and now I'm a little surprised this worked. It got all the way to the assertion, which is kind of strange actually, because I would have expected update signal to have been called. Oh, I know why it isn't, because we never told this to update the trace. So actually, the whole thing built and ran. It's just that we never told the sim to update the trace, so the trace is empty, and we never hit that to do. That's what happened there. Now the nasty part is that this sucks to read. That's definitely more annoying than I thought. But whatever, we'll hack this case and then I'll be done for today. This is good enough progress. So let's see. Actually, before I dig into that, you can see that this. Well, yeah, this basically won't include anything, but I think yeah, this does capture I0. No, yeah, this is the input. So we have like O1, I0, I4, I1. That's pretty cool. It's a good point. I might as well add, I might as well implement debug explicitly to make this easier to read. That's probably worth doing. Yeah, I won't do that yet because it's annoying. I'll definitely want to do that while I add these other ones. I mean, it's really just to read these outputs, but still probably worth doing. And then yeah, I might also make macros around some of this other stuff. We'll see. It's not the ugliest thing in the world, but it's definitely not the prettiest thing in the world either. Luckily, I don't think these graphs will get terribly large, actually. But yeah. I wanted... What did I want? Oh, Tests, yeah. I wanted to look at how this was used here. So in this case, there's no reset. We don't have to worry about that because this module isn't stateful. So I think it's just basically m.i0 equals whatever. In fact, these will be default initialized. So I might as well test those initial values. I think that's probably an okay thing to do. And let mute timestamp is 0. Ooh, 1 second. I just saw that this inferred the timestamp is I32. That will not do. I better not have messed that up in trace. Okay, timestamp is U64. So I don't know how that was inferred like that. Maybe it just wasn't up to date or something. But this timestamp, since it's used in update trace, should definitely be U64. Whatever. Yeah, because we also want to do stuff like this, which is just good practice. Because there's a difference with these tests now is that the generated trace code needs to handle the fact that the trace might generate errors, like the IO errors. So we want to propagate that up in these tests, although in the other ones that never happened. I think with this we'll hit this to do, and I think I want to do that first. There it is. Great. Yeah, I guess that is true. This doesn't need to be mutable. It's kind of fun. Timestamp will be mutable because we're going to mutate that for sure. And then the value and the signal ID, we will get those here now. So what this will do, yeah, we should be able to do something like this. Signal ID dot, isn't it get mute rust RC? Always have to look this up, but it's fine. Oh yeah, we can't do get mute because we clone this. But that's actually fine because I think if we do dot, we can just get the values like this. So dot values dot borrow mute. That's what we want to do. So this is a borrow at runtime, which is fine. And then, yeah, then we'll push. And we'll push self.timestamp, and then we'll push the value. That's it. And that's why I wanted to use these RCs, so that we can give the signal ID and just unwrap it here instead of having to like walk the tree and go and find the signal that it meant from some simpler type. Yeah, and then those warnings go away, which is great. And now it looks like it's hard to read. So maybe I will actually change that format thing. I just don't want to dig into that yet, but maybe I need to. But at least we can see that like it's a lot larger. So I think we actually have captured all of the signals at least. We just haven't captured all the values and what we compare against. So kind of cool. Yeah, I'm gonna derive or implement debug for capture module. We'll start there. All right, let's just do this. I'm just digging through some docs about this. I always forget how to do this well. Hey, Kiris, it's going well. Married life's treating me great. It's really nice. Thanks for asking. Oh, yeah, we can just use right like this. Okay. That's what we'll do. I'm falling apart over here. Getting tired, but let's push through and get this last little bit of this test done. And then I'll feel really good for this week. Let's see. You know what I could do? Start with that. Yeah, that's great. I could do this for capture even. In fact, I think I'm gonna, just to even make this root prettier, I'll do that. might even just do the whole thing in here. Wouldn't be anything wrong with that, I think. I actually like to do this, even for simple stuff like this. Just to separate this, just makes it code a little more uniform, I think. It would kind of be nice if Formatter gave us like a nice way to maintain indentation. Maybe it does, and I just don't know what it is. Thanks, Curious for the highlight. I don't think I make money from that. I think I make money from subs. And then I think you guys can use that. I think that's what it is. Yeah, I still haven't set up emojis. Sorry about that, guys. Thanks for the sub, though. Really appreciate it. Just going to add another reminder to do that. I'm just going to ignore indentation for now. Like, do it by hand. Probably a dumb thing to do, but I think it's fine. Yeah, let's do that. All right, so then we have the module, and then we can do something like let me indent 0. We can recurse like that, and then maybe I can give the indent level to this. I don't like that much, though. Yeah, I'm still going to do this recursive thing. Actually, that won't help, because it won't make it recursive. If I make this a function in here, that'll work, though. Because I know I want to recurse into the other modules, so that's still useful, but yeah. That's actually fine for that. Like that. We can do signals. Let's see. I may want to change these to a B-tree map. Just to make it easier to read these traces. That's a pretty typical thing I like to do. You use a map that will introduce some kind of ordering. So when we insert, like we're basically inserting, we don't care about the order. But then when we're reading it out to compare the two, then we'll at least get all those in the same order for sure. I like to do that. Just easier to debug stuff. So then that'll be signals .iter. Something I might do here. Yeah, so here we get some defined ordering on the signals that were captured. And then, yeah, this is the one that we made synthetically, which doesn't contain all of them, which makes sense. So it's actually nice that we see that at least. You know what I'm thinking about doing is I'm thinking about taking basically the code writer thing that I have here. This says public, but I think this is only public within the crate because code writer is not public. I don't want to make that public. I think I just want to kind of copy something like it. Yeah, it's in another crate. It's in the kaze crate, whereas we're doing the tests crate. Yeah, Formatter has all these like helpful things for this, but I think they're actually not what we want because I want to enforce a particular style here. So I think I'll just continue doing it myself and not care about the formatter really, other than basically treat it as a writer, which is what's happening here. I'm just straight up going to copy this. More or less. And stick it in the tests for now. And we're just going to deal with cleaning this up later. Think about basically doing something like this. Does that work? I hope so. I'm getting so lazy with this. But whatever. So then what I'll do is and these will basically all change. whoops, to w dot append line format. Not super pretty, but this is kind of the point, is that now we have w dot indent and w dot unindent. For some reason, unindent does this. Why is that? I don't know. I think I meant for this to return an error instead of panicking, but apparently I didn't do that. Whatever, I guess. Maybe I'll fix that. Oh yeah, this used to be an IO result, but if it's just a format result, we don't need that. And then this formatter, this other lifetime. I don't know if this is correct to do that. I don't know, so we'll see. Right, the print module. Here, we want W. And then, yeah, new, since we had this lifetime here, we need to do that. And yeah, when this recurses, it needs to be, no, that should work. Oh yeah, and mute. Almost. I didn't like these lifetimes. So close. Yeah, because we made these the same. I think we need to do this. And yeah, this needs AB. Yay. Right, now we have some kind of indentation. Fantastic. It's got a bit silly, but I think this will go well. Great, so now we can do this. And I actually think using these curly braces is not that useful, because if we're going to indent anyway, I think we can just do basically this. And I think this will get a little cleaner. So here we can do Chirin. For name. I think that will work. It's not used anywhere, but then we remove a to-do there. Yeah, so no children. And then, yeah, so now the signals, we can basically do the same thing here. And then the values. in fact, here I also want to do the type. Is that all we had for signal? I don't remember. Bit with type values, great. So then we write that. Bits might be 1 bit. And then yeah, so this will be signal dot values dot borrow dot iter. Yeah, we could just rely on this other debug formatting for the other stuff. Yeah, this was probably worth hacking together now. Yeah, this is obviously much easier to read. And I'm running a little late streaming today. Oh shit, no, I'm running really late now. It's been a few hours. Whoops. Okay, I did not mean to stream this long today. All right, I'm actually going to go and pick this up later, but I think this is good progress. All right, anyway, thanks guys for hanging out. I'm going to see you next time.